This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2018 AP Calculus exam free response question AB6. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I'll present some specific scoring examples. In this free response question, we're given a differential equation in terms of x and y. In Part A, we're also given the slope field that corresponds to this differential equation, and we need to sketch two solution curves, one through the point 0, 2, and another through the point 1, 0. In Part B, we assume that y equal f of x is a solution to the differential equation with initial condition f of 1 equals 0. We need to write an equation for the line tangent to the graph of y equal f of x at x equal 1, and we need to use this equation to approximate f of 0.7. In Part C, we need to solve the differential equation. That is, we need to find the particular solution to the dE with initial condition f of 1 equals 0. Part A was worth 2 points. Very simply, 1 point for sketching the solution curve through the point 0, 2, and 1 point for sketching the solution curve through the point 1, 0. Part B was also worth 2 points. 1 point for writing an equation of the tangent line to the graph of y equal f of x at x equal 1, and 1 point for using this equation to approximate f of 0.7. Part C was worth 5 points, and these points were earned, or another way to think about it, partial credit was awarded, along the way to solving this differential equation using separation of variables. The first point was for separating the variables. The next 2 points were for the antiderivatives, 1 point for each side. The fourth point was for introducing a constant of integration correctly and for using the initial condition. And the last point was for putting everything together and solving for y. Here are some general comments about student performance on this question. In Part A, students needed to sketch 2 solution curves. Unfortunately, some simply did not sketch the solution curve through the point 0, 2, and I'm not sure why. And some students confused the scale on the axes and the distance between line segments representing the slope field. It appeared that these students assumed that the distance between tick marks was 1, not 1/3. In Part B, some students actually worked to solve the differential equation. That's the work for Part C. Most students were able to find dy dx at the point 1, 0. And some students made errors in simplifying the approximation. Remember, the final numerical answer does not need to be simplified on the AP Calculus exam. In Part C, many students made errors while trying to solve for y before using the initial condition. Most students were able to find the antiderivative of the linear term here. However, to find the other antiderivative, many students introduced a natural log function involving y. And, as is common in these problems, some students did not separate the variables at all, and some did not separate the variables correctly. In Part A, the first point was for a sketch of the solution curve through the point 02. So simply, we need to see a horizontal line through this point. The second point in part A was for a sketch of the solution curve through the point 10. Now, here the student has to be a little bit more careful in sketching the curve. The curve must be continuous. It must extend from the left boundary of the given graph to the right boundary. It must be relatively smooth, which is a subjective reader judgment. And the curve cannot cross the line y = 2. The phrase extends to the boundary really means the following. We will read across one gap in the slope field with the student's solution curve. So the curve can stop one gap in line segments away from the boundary. And many students use arrowheads at the end of their solution curves. In this question, we only considered or accepted arrowheads on the horizontal solution curve if the curve did not extend to the boundary. And I'll show you an example of this kind of a response in the next slides. Here are some specific examples and the score for each response. In this first example, unfortunately, neither solution curve passes through the appropriate point. So this response earns 0, 0. In this example, the solution curve through 0, 2 is correct, but the other curve crosses the line y = 2. So this response earns 1, 0. In this example, the horizontal line at y = 2 stops one gap away from the boundary, so this earns the first point. And the other solution curve is pretty good. It earns the second point. And in this example, the horizontal line at y = 2 has arrowheads. So even though this stops more than one gap away from the boundary, this earns the point. The second solution curve has arrowheads also, but it must extend to at least one gap from the boundary. So this does not earn the point. The first point in part B was for an equation of the tangent line. This was awarded for an equation of our tangent line, and here are two common responses. If the student earns this point, it's in the bank. That means they cannot lose this point. Any subsequent error means the student does not earn the approximation point. The second point in part B was for the approximation, minus 0.4. And remember, this approximation is a final numerical answer, so it does not need to be simplified. It was possible here to earn a 0.1 in part B without writing an equation of the tangent line. Note that this question did ask for an equation, so there was a point allotted to this response. A bald minus 0.4 did not earn the approximation point. There had to be supporting work. And the correct approximation has many forms, of course, and here are a few. Any additional work in part B unrelated to the tangent line and the approximation was not read. However, depending on the work, it might be considered later on as a response to part C. Now this is a little unusual. We don't normally read for answers in other parts of the problem. In part C, the student needs to find a particular solution to the differential equation. The first point is for separation of variables, and we'd like to see one of these two expressions. Each earns the first point. However, there were other good separations also, or other expressions that conveyed separation of variables. And here are a few. Some students started this problem by separating the variables and finding the antiderivative of both sides all in one step. These two expressions would each earn the first 3 points. If there is a bad separation, for example an algebra error, the student does not earn the first point, but may be eligible to earn the middle 3 points. And there were some special cases here, and I won't go into these in detail. They involved a missing x, missing differentials, or a mishandling or a copy error involving the constant or the difference. And we had a very fair way to score these responses. And if there was absolutely no separation of variables, the student earned 0 of the 5 points in this part. The second and third points in Part C were for the antiderivatives, and there was an eligibility criteria here. The student must have earned the first point or be in one of the special cases as described on the previous slide, or have presented a bad separation expression in which all the y's are on one side, all the x's are on the other, dy dx is handled correctly, and one side is correct. And yes, you're right, we have to read these responses very carefully. Each point here is earned for the correct antiderivative, and an earned antiderivative point is in the bank. Any linkage errors and all subsequent errors, and the student cannot earn the answer point. The fourth point in Part C is for the constant of integration and for using the initial condition. The eligibility criteria to earn this point is the student must have earned at least one antiderivative point, and both variables x and y must be present in their expression. This point is earned for presenting 2 steps in this solution process: for substituting 1 for x and 0 for y, and for including an arbitrary constant consistent with the presented antiderivatives in an equation that can be solved for the constant. There are some cases in which the student could use the initial condition and a constant of integration, yet not earn this point. For example, if the substitution creates a non-real expression or a non-real constant c, or an unsolvable equation, or is used with a constant c not consistent with the presented antiderivatives. And finally, the fifth point is for our answer, a correct expression for y. And there were many forms for y, and here are a few. And even though there is a domain for y given in the scoring guidelines, this was not necessary in the student's response. Any domains presented were not considered. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.